Hello friends, welcome to your own YouTube channel Mechanical Engineering Tutorials. Friends, in this tutorial we will be seeing few more commands used in the surface domain in Catia v5, that is surfacing in Catia v5. So this is going to be the part 2 of the tutorial video. So in this tutorial we will be seeing few operations like join, disassemble, split and trim, boundary, extract, symmetry, extrapolate. Friends, we know that Catia is a very vast software and there are numerous amount of operations that are involved, but we will be basically focusing on those operations which are relevant to industrial design, specifically to automobile design. So to know more about these operations, please stay tuned with this tutorial. So before we begin with this tutorial, I request you to please subscribe to this YouTube channel if you have not yet subscribed. Click the bell icon for the latest notification of the videos on this YouTube channel. Follow us on Twitter, Instagram and like our Facebook page, Mechanical Engineering Tutorials. So friends, let's begin with the tutorial. So now we shall move to the Catia interface. So welcome back to this Catia interface. So as we have said that we will be covering here the important operations like join. Then within the join we have disassemble, we have untrim. Then we will be covering the split, we will be covering trim. Then we will be covering here the boundary, we will be covering extract, then we will be covering the symmetry, and lastly we will be covering the extrapolate. So in the previous tutorial we have already seen the extrude, offset, sweep, fill, multisection and blend. So you can refer to the part 1 of this tutorial series in the I button which will appear on the top right corner. So now coming to this tutorial. So on the screen what you see are some set of surfaces. So before we start with the actual operations, I need to throw some light over here for you to understand very quickly. So when we consider the automotive design, we know that before a vehicle comes into market, numerous operations are done in the back end. That is, a start from the concept design to the final automobile takes place. So once the concept design is approved, which is usually a hand sketch which is done by designers, a clay model is prepared which will resemble the final vehicle which will be launched. So this clay model will be to the actual scale of the final vehicle. So from the scale model, the surfaces are scanned, and those scanned surfaces are recorded in this fashion over here, what you see on the screen. So these surfaces will not have any parent-children relationship. So we already know what are parent-children relationship as we have seen that in the part design. So these surfaces are known as the dump surfaces. So here the surfaces are usually obtained by scanning the clay model, and the surfaces which are visible to the passenger or the driver when inside the vehicle or outside the vehicle are the one which are scanned, and these surfaces are called as A surfaces. So basically if you take any automotive door trim or instrument panel coming to the interior part in the automobile, the door trims plastics which are visible to you when you sit in the vehicle, or the instrument panel which is visible to you when you sit in the vehicle, The surfaces are the A surface, which are obtained by scanning the clay model and recording those surfaces. So these surfaces are sent to the designer in these forms, which does not have any parent-children history. So using this surface, the final 3D model will be prepared. So to prepare that, the numerous operations will be used. So basically, the first and the foremost operation which will be used is the offset. So we have already seen in the part 1 of this tutorial what is the offset command. So by creating the offset, another surface called as B surface is created. So B surface is that surface which will be behind the visible surface. Say for example, if you take an insert which is in the door trim, the surface visible to the passenger of that insert will be the A surface. Say insert will have some thickness around 2.5, which is the general specified thickness 2.5 mm, and exactly the replicate surface will be behind this A surface with a thickness of 2 mm, 2.5 mm. So this B surface will be created by offset, and later on the thickening will be done. So that we will take up in the later part of this tutorials with an specific exercise. So these surfaces, which are usually single surfaces, they need to be created into one single surface, and for that we make use of what is called as the join command. So here we start with the first command, that is the join command. So when I click on this join, so you can see here there are multiple 4 surfaces which are split, and as soon as you move your cursor on the icon changes to the joined surfaces. So you can just look here. The cursor, as I move, the icon changes. So this is the join surface command. So when I click on this, it will ask me to select the surfaces I want to join. So I want to join these 6 surfaces which do not have any parent-children relationship. So I select the first, second, third, fourth, fifth, and lastly the 6th. And here the merging distance. So merging distance is that distance which is the minimum distance between the two surfaces. So if you want a very smooth surface, then we need to keep this merging distance as small as possible. So again, here I'm not going to get into more detail, because in automotive industry, this value of merging distance will depend upon the OEMs, that is original equipment manufacturers. So here I'll take the most stringent value of merging distance, that is 0.001 mm, and I'll just say OK. So as soon as I say OK, you see there will be a color change in the surface has taken place. So what does this color change indicates? So this indicates a single surface is created. So if I just change this view to the plane view without any edges or smooth edges, you can see here the lines which were present earlier have now disappeared, and this has become into a single entity. Though there are some edges which are present, that is because of the merging distance problem over there. So we'll not worry much about that, as this is for the tutorial purpose here I'm taking. So this has become into a single surface. So this is about the join operation. Next, we have a condition wherein a single surface will be scanned and sent by the OEM to the designer. And with that single surface, the designer is unable to perform any operation. So he needs to split that surface into multiple surfaces. So in that case, a command called as disassemble will be used. So that will be in the join itself. So as soon as you click the arrow below the join command, you will get numerous other commands, and in this the last one is the disassemble. So what does this disassemble do? So when I click on the disassemble, it will ask me to select the surface. So the joint surface which I select here and say OK. Now it got disassembled into the previous primary surfaces. So suppose if I hide this join, we'll get a clear idea. So the join is hidden now. Now when I disassemble the join, it got disassembled into numerous simple surfaces. So this is about the disassemble. So next command we have here is the split command. So to perform this operation, we need to create another surface here. So for that, I'll have to create one surface. So I go to positional sketch, I'll go to this YZ and click OK. So here I will draw a simple straight line without constraining it, because I just need it for the explanation purpose here. Next I'll go to extrude, which we have already done in the previous. So here by default it will take horizontal, but I want this to be in Z axis. So I'll just take this extrude as Z axis. And once I selected the Z axis, I'll just select its length. Slightly above. Now here, say for example, I need only the inner surface in this profile to be retained. So in that case, what I do is I have to perform the split operation. So I go to split. I need to split this surface with respect to this surface here. I'll just say the other side. So here the top portion will be removed. But since I have selected only the horizontal surface in this case, that has happened. So I need to perform the join operation first. So what I do is I'll go to the join and I'll join these into a single entity here. Say OK, and this has been joined to single entity. Now I'll go to split. I'll split this with this and say the other side. Now if you notice, the outer surface has become blurred, whereas the inner surface is not blurred. That means that will remain. Say OK. But here what has happened now? The split surface is one surface and this joint surface is another surface. And suppose you want to create these as one surface, again you need to go to join and join both these surfaces. So here you will be conducting a split operation and then a join operation. So to replace these two operations, a single operation is done, that is called as the trim operation, which is within the split operation. So let us undo this and we will see what is this trim operation. Now when I click on the arrow besides the split, I go to trim. So again here it is also like the split only, but what is the difference here? So I need to remove this with this. Now here I have to select the other side. Okay, and when I select the other side, this surface will be removed and say OK. Now if you notice, this has become a single entity. In earlier case, you had to split it and join it. So there would be two commands that would become split and join. So for that reason, we should avoid that. We have a simple command called as trim. So basically this is the difference between split and trim. So once the split and trim is done, we will go to the next operation, that is boundary. So what I'll do is for this boundary, I'll click on this. I have to select the surface or the edge. So I want this boundary of this surface created. And when I say OK, I'll get the curve which will resemble all the edges of this particular single surface. So suppose you want any of the edge of any surface for your construction purpose, then you can make use of this boundary. So it will extract the edges into a single curve. Here you can see this as the boundary. So let me hide this line, it will create confusion. So here you can see this white edge which has been put here, that is the boundary operation which can be done. Suppose you want any edge. Now suppose you want any surface for your operation. Then we can have a command called as extract. So when I go to this extract, and here I need to extract say this particular surface, the surface will get extracted. Say okay. So I'll just change this property and I will change its color to say purple and say okay. So here this you can see this is the extract. So when I hide this, the original surface is there, and when I show this, the extracted surface will come. So here we have boundary that is used to extract the edges of the surface, and we have extract to extract the surface itself. Then we have something called as multiple extract. So this will help in extracting multiple surfaces at once. Say for example, I want to extract this, I want to extract this, I want to extract this. So multiple surface I can select here and say okay. So here I get a multiple extract. So I just change its properties, you will get a clear idea. I'll make this say as blue. Not this blue, I'll change this to this maroon color. Okay. So this is now multiple extract. So multiple extract will help us to extract in one command multiple surfaces. So these three are very important commands which are used in the surface. So I just undo this both extract and multiple extract. Also I'll remove this boundary and remove this. I'll not remove this one. Okay. Next we have is the fillet. So usually in this fillet we have the edge fillet. So when I select the edge fillet, I have to select the edge of the surface. So I have selected the edge. So over here, and if I give here this as 10 mm, say preview. Okay, a surface of 10 mm will be created. I just change this view, you will get an idea. But usually this is not widely used, so I didn't include this in the agenda of this tutorial, because once the final 3D part in the part modeling is done, so this fillet can be given in the part modeling itself. So usually more complicated operations are avoided in surfacing. So in surfacing only those operations are done which are not possible to be done in part modeling. So for that reason we need to make our final surface very simple as possible. So I'll just undo this edge fillet. Next we'll go to what is called as the mirror or symmetry. So for this mirror or symmetry, I'll be deleting all these which we have done, that is the join specifically. So in this surface I'll remove 1, 2 and 3. So these three surfaces I'll delete. So symmetry will help in creating the carbon copy or mirror copy of the existing surfaces. So first, second, third. So reference, I have to select here my ZX plane and say okay. And here if you see, these three surfaces get copied or mirrored image along ZX plane. So this is about the symmetry. Next we have something called as the extrapolate. So suppose you want to extend the length of any surface. Say for example this is the surface. I want to bring this surface slightly ahead. Then I can go for this extrapolate. So I'll click on this extrapolate. I have to select the edge and the surface, and here I can specify the length, and that length extension of the existing surface will be done. So you can see here this is the extrapolated surface which is done. So extrapolate is similar to extrude, but for extrapolate we need to have the edge and the surface, or a surface is necessary wherein you can extend the edge with the surface as the support. Whereas for extrude, you don't need any support, you just need the tooling direction and the sketch or a line or a curve, anything that to which the surface can be created. So these are few other set of commands which we learned today, that is the join, disassemble, split, trim, boundary, extract, symmetry and extrapolate. Okay, so that's all we have here today in this tutorial. So thank you very much for your patient listening. So before we end this video, I again request you to please subscribe to this YouTube channel, click the bell icon, follow us on Twitter, Instagram and like our Facebook page, Mechanical Engineering Tutorials. And also you can have the videos on other topics on this YouTube channel. Thank you very much.